let's talk about differences between string builders and strings. In Java, there are actually 3 string-like classes. When I say string-like, what I mean is that sequences of characters are stored. Now, when a computer scientist says sequence, what they mean is order is important. So, for example, ABC is different than CBA, and that is certainly true in the case of sequences of characters. The first class is called the string class, and you've seen this one quite a bit. Now, it has a special syntax to it, and that can be both good or bad. So I've talked a little bit about the fact that when you have a string name equals double quote ABC double quote, that's actually calling a constructor and building a new object. This is something that's sort of curious in Java. The way I look at it is this. If you think about human language, you'll find that the most commonly used things become irregular. So, for example, if you've ever spoken a foreign language, you'll find that it's very common for the verbs to be, to make, to do, to be highly irregular, even weird at times. Well, guess what? That happens in synthetic language too. It's really quite amazing. Now, the string object has a very unusual property. It's called immutable. What that means is once you create a string object, you absolutely positively cannot change it no matter what. And that is kind of strange and has some important consequences that we'll discuss today. Now, the string builder is very similar to the string, but the difference is it's mutable. That is, the characters can be changed in it. There is a third string-like class. It's called string buffer. Now, this one has a unique property called synchronization. Synchronization is a very advanced topic in programming and one we're not going to approach this semester. So we're not going to use the string buffer class at all. When you go to access string properties, you can do it like this. First, you build the string object. So we could say string name equals new string double quote Sadie. Name.length will return the number of characters in the string. Now, length is unit indexed. When I say unit indexed, I mean we start counting at 1. So Sadie has 5 letters in it, and that's what will be returned. You also can find out what the individual letters are by asking for them by number. So name.char@0 returns a capital S. Now, you'll notice that the letters themselves are 0 indexed. So the first letter is 0, the second one is 1, the third one is 2. That's going to seem a little weird at first, and it is certainly the source of a lot of mistakes for beginners, but you will get used to it soon. Here's the pattern for calling methods that are in the string class. We have the reference to the object, and then a period, then the method names, and then any arguments. Now remember, there may be arguments, there may not. It just depends on which method you're calling. So for example, the length method doesn't have any arguments, but the char@ method does have one integer argument, I might add. All of the methods that are available in the string class are documented in the API. To lowercase is an example of a method that's in the string class. What this class does is it changes any uppercase letters that happen to be in the string to lowercase. Now wait, you should be thinking, just a minute ago you told me that strings are immutable, and strings are immutable. But what it really does is it creates a new string object with all lowercase characters. So it takes the ones that were uppercase and it changes them to lowercase. And then it returns the reference, which remember we can store or not store as we prefer. Now let's take a look at what this means in a memory diagram. So if we say string name is new string Sadie, this is what we have as a string object in memory. Notice the reference name points to the object that's stored on the heap. Then we say name equals name.toLowercase. Now name.toLowercase creates a new object. Notice it's Sadie with a little s. It's not changing the original object because the original object is unchangeable. Then, because we stored the reference that was returned by name.toLowercase, in name itself, the reference gets replaced. So notice, right over here, on the left-hand side, we're pointing to the new object that's in lowercase, and the reference to the original object has been lost. So at this point, this object, the one with Sadie with a capital S, That one is going to disappear when it gets garbage collected. Now, the other thing to notice here is what we're dealing with is a hidden constructor. That is, the toLowercase method is constructing a new string object inside the method itself, and it's returning it. So these hidden constructors can cause a lot of grief in Java. We need to look for them very carefully. Now let's talk about a string builder. String builder is also a sequence of characters, but this time it's mutable. That means we can make changes to the object without reconstructing it. The access is very similar to a string, and in fact, some of the most useful methods are identical. So if we could say string builder name equals new string builder and then Abby in double quotes. Now, string builders are not that common a class, and so they don't have any special shortcut operators like the string class does. So all we have is the regular constructor. If we call name.length, now on our string builder object, it's going to return 4 because Abby has 4 characters. If we call name.char@0, this returns a capital A because the 0th character of the string that the reference name refers to is a capital A. Remember, char@ uses 0 indexing. Now for mutating. If we start with a string builder name equals new string builder Sadie, this is what we have. But remember, the string builder is different than the string. So if we call name.reverse, what happens is this. The characters inside the original object get changed. So instead of having Sadie, we have Edis or something like that. Sadie reversed. Notice we did not have to assign it for this to happen. So this is a very different mechanism than what we've seen in the string class. And all of this has to do with whether the objects are mutable or immutable. Now what this means is inside every program we have some really tough software engineering decisions. Strings are more efficiently represented than string builders. Now the reason is the string builder needs to have some excess capacity, so if you make changes, it can respond to them. Excess capacity is wasted if changes aren't needed. Now, if no changes are needed, or if very minimal changes are needed, you're probably better off using the string. If changes are definitely going to be needed, then you need to use the string builder. So this becomes an important decision that you make with every single program that you write. String, string builder. And it all depends on whether you think the objects are going to change or not. So keep programming.